waiting for. Hello? Yes, maybe a little bit louder. Test 1, 2, 3. Test. Test 1. Test. I think it's good like this. Oh. Let's see. Okay. Well, welcome everybody. If you want, there's also some benches in front, but I guess the chair is a little bit more comfortable, so it's good. Who here probably knows which question I'm gonna ask now? Okay, so that's a few. Okay, so for who of you is this the first NLHTML5? Okay, let's almost the same amount of people. So for those who are new, let me just quickly explain what NLHTML5 is about. We are a front-end meetup group, which is pretty obvious from the title. We don't do just HTML5, but we also do anything front-end and closely related to front-end. So we're almost at 2,000 members now, so yay, maybe a little bit party next time. Nice applause, thanks. So we do monthly meetups. We also have maybe a hackathon planned next month with Twilio. So if you're interested in that, sign up for that. Because if not enough people sign up, we're not gonna do it, because otherwise it's just a waste of most people's time. So what our aim is to help the community to bring like the best and most interesting speakers and topics for free to everybody. And we've been doing that for ever since I think 2016, I want to say, 2015. 2015? Okay, January 2015. Thanks. So and we're having lots of fun with that. We also have sponsors, which I'm gonna introduce if this thing is working. Oh, of course, CSS Day. Who here is going to CSS Day tomorrow or the day after, something like that? Yes. That's quite a few. I won't be there, sadly, but I hope you all have a lot of fun. CSS Day has sponsored this meetup as well, and yeah, I hope to see a little bit more on the videos as well. So it's gonna be pretty great, I guess. Our host for tonight is Workspot. I want to invite Sasha up here to talk a little bit about Workspot itself. So. Small applause for Sasha. A little bit bigger than. Okay, good.
Hey guys. Right. I'll keep it brief. I know you want the real good stuff, so okay. All right. My name is Sasha Derozna. I'm one of the technology managers here. We're really passionate about technology in general, so and open source is something really close to our heart. So this is the reason why we're having you guys here. We also contribute quite a lot to open source. And even some of our code is open sourced. So if you're interested, go check it out. So yeah, all love for HTML5. I didn't get your logo in, I see, but for next time, yeah. Okay, so what are we about? We're an online marketplace, and we're matching people at home who want something done. Maybe painting, maybe you're wanting an extension on your house, something like that. And our platform and our aim is to be the easiest and most reliable way to arrange home services. Currently, we're in both Italy, the Netherlands and Italy. This is not to scale, just so you know. Yeah. So we launched in the Netherlands quite a while ago, a number of years ago, and Italy we've been there for a couple of years. We're actually part of a bigger network of companies, and some exciting news for us that came recently is we're having the opportunity to re-platform the French business Travaux.com onto our platform. So that's quite a massive jump for us. We're pretty happy about it. My builder is in the UK. My hammer is in Berlin, or in Germany. All right, we have a lot of interesting challenges on the platform, and one of the most interesting is keeping things in balance. So we have two types of users, as I already explained. We've got guys sitting at home, and we've got ones that are able to do the work. And keeping this in balance is often a challenge. So we can have in a specific area, because people work in specific areas. So maybe in the northeast of Holland, there's a town, and someone's looking for to fix their tap. We can have a few people that fix taps in that area. And then what happens is we end up with an unhappy customer. He's put a job, but he didn't get it actually fulfilled. So liquidity is a term that's used. So having a good balance of the people is something really important, and that's something we're continuously trying to improve. Can actually happen the other way around as well. So there's too many guys who can fix taps in that small little town, but not enough people putting job requests on, which ends up with a facepalm. So we're trying with many innovative ways to improve the way the platform is working. So we use some data science and machine learning. And we're also trying to make an awesome front-end stack which can give the users a really great experience. So we need to continuously be agile and flexible in the way we're working. We run a lot of lean experiments. This is a diagram of the stack that the front-end guys, Paul and Sakis, you can ask more to them afterwards, setting up the new stack for this year. So we're looking to have, with React.js, Apollo clients, Node.js backend, and all sorts of great stuff. On top of this, or actually underlying this, we're using Kubernetes and Docker to really make it a lot more flexible and scalable. So this should be up and running very shortly. And we have strong core values here at VaxSpots. If you end up talking to any of the guys here, these terms are used really a lot. It's amazing how alive it's kept in the company. And we actually are really big on celebrating our achievements. This was King's Night, sorry, not so long ago. And this space was also opened. We kind of went through a renovation recently. So that's it pretty much. I hope you enjoyed the food. It's the first time we're having for a tech meetup this Italian food. We normally have Suriname, so if you come back next time, we'll have maybe some variety. It might be Suriname, might be something else. And help yourself to drinks. Smokers, in case you didn't already, Paul didn't tell you already, through on that balcony at the back there with a bit of sun still. Go and have a puff there if that's your thing. I actually don't have my name badge, it's on there. But if you see someone with a name badge, you're welcome to speak to them. We're working here. Paul, where's your name badge? Okay. Okay. He's the organizer. Sorry. Okay, you don't work here. So thank you for coming and enjoy. One last thing. We're hiring.
Okay, so thanks. So our one of our main sponsors is Mozilla. I normally make the assumption that everybody knows Mozilla, but for those who don't, they make a lot of cool stuff like the Firefox browser, the Rust language. They have the Mozilla Developer Network documentation and stuff like that. And there's Google Developers. Google Developers is an API platform, documentation platform which has APIs, but you can also ask questions to Google experts on that. And one of our partners / sponsors is Frontiers. Frontiers is a I should really look this up. It's sort of a guild. It's for front-end developers, and they also have a conference. So they have meetups and workshops, but also a conference. And the conference this year is October 4th and 5th. There's a lot of great speakers. One not so great speaker. So yeah, there's still tickets available. So if you're interested for that, then go to frontiers.nl or frontiersconf.com. It's frontiersconf.com, because otherwise you'll end up on a Dutch website. Then there's also RefreshConf a few weeks later. Joel's here. Do you want to say a little bit about Refresh, or just a little bit? Okay. Joel is one of the organizers of Refresh Conference, so give him a little applause.
Hi, I'm Joel, and I brought a ticket. It's there. And we're giving it away today. Boop, boop. Oh, and by the way, we also have very cool speakers. Yes. Yeah. That's it. I won't bug you any longer.
Thank you. And there's Beyond Tellerant, who is always helping us out with, well, they helped us out in the beginning with the organization, but now are also give tickets away very frequently. And yes, we also have a ticket today to give away for the Berlin edition of Beyond Tellerant. They also have conferences in Düsseldorf and München. Thanks. And I want to remind you, or just tell you, that we have a code of conduct. If you want to read the full code of conduct, it's on the meetup page. Basically, it means that just be decent to each other, don't harass each other, and if there's any thing that happens with you or with someone else, and you want to just talk about it, come to me or one of the other organizers, Lara and Damien over there, and we'll figure it out to help you and assist you in this matter. So this is not a correct schedule anymore. The order is correct, the times are not correct. So we'll start off with Lian, who's doing a talk about machine learning. Afterwards, well, Damien, who's also the organizer, will give us an accessibility talk. Then we have a 15-minute break, and then we'll do the raffle. And then Schepp, where are you? There's Schepp. He'll give you a talk about browser APIs, and afterwards we can still have some drinks and some snacks. So this, let's see. So I want to invite Lian upstage. There you are. So while she's setting up here, I'll just give her a little introduction. So I've met Lian, I think, last year at Wood.js for the first time. It's a conference in Germany. Also in October. There's a lot of conferences in October. And I've seen her a few times since. So if you have met Lian before, then you know that she's passionate about her unicorn onesie. Or dragon onesie, sorry, dragon onesie. Her unicorn / dragon hair. RuPaul's Drag Race is also something she can talk a lot about. Her never-ending rivalry with her namesake, which we will probably talk about today. But also about machine learning. And even though all these topics are extremely interesting, I'm happy that she's here today to give us a talk called Machine Learning in the Browser. Give it up for Lian.
I have the exact same clicker. This is going to get super confusing. Everyone has this clicker. All right. Thanks for the nice applause, and thank you for the nice introduction. Yes, I'm going to stand over here. So basically that's everything you need to know about me. And also please come and talk about RuPaul's Drag Race with me. This is my all-time favorite topic. But today I'm gonna talk to you about how to do machine learning in the browser, and maybe you can do something cool with machine learning and Drag Race. Let's talk about that. So, yeah, I'm gonna introduce myself real quick. This is me. Like Paul said, there's also another company with the same name. And so usually I introduce myself with saying, this is not me. This is a computer case, believe it or not. And my whole life, basically, I have to deal with stuff like this, where people post things on my Facebook timeline, and this particular person was so happy about his find that he posted it, liked it himself, and then after I liked it, like posted another smiley. This is all the same person. Or a few, like last week or so, I think. So I moved to Amsterdam 3 months ago. My new colleagues also discovered that there's this company, and then they asked, like, is that our Lian Li or someone else? And I'm thinking, this is clearly a company. This is not a person. Like, read the article. And then someone's like, oh my God. And every time people like tell me this, they tell it to me like, oh my God, you have to see this. You probably have never Googled your own name. Or okay, I've been in this industry for like 7 years or so. So clearly, I have heard of Lian Li. Yes. So let's not talk about that, because that one's pretty annoying to me. Anyway, so if you want to follow me personally, not Lian Li, this is where you can follow me on Twitter, on GitHub, and on Mastodon, where I post like once a year maybe. So maybe try the other ones if you have something urgent. Anyways, yeah. So I am a software engineer by day, and am a machine learning enthusiast by night. So my job does not necessarily have anything to do with what I'm going to tell you about today, but I will say a few words later. Anyways, so just so you know, I'm getting surprised by my own slides now, because I can't see the next slide on my laptop, so bear with me if I'm getting confused in the middle. So we're going to talk about machine learning, and I just want to give you like a short oversight about what machine learning actually is, how it works, compared to what I call expert systems or conventional programming. So the difference between machine learning and expert systems is basically that in expert systems, we have an input, and we have the rules that we want to follow. So for example, we know that we want to have something that adds 3 to any given number, and then we have the rules, which is probably like a function that takes a number, adds +3, and then the input, and then we get an output out of it. Whereas in machine learning, we have the input and we have the output, but we want to get the rules out of this magic machine learning box. So we don't have to come up with the rules ourselves. The machine learning algorithm does that for us, basically. So everything everything comes down to input and output, which is our training data, or just data that we need to put our most of our effort in. All right, data, yes. Okay, so to reiterate this, giving you another perspective on this, is that, in machine learning, we learn from experience, which is the number of different data points, so a broad variety of situations that all contribute to the same pattern, and of repetition, which is the number of training iterations. So taking all this experience and iterating a lot on it, that is the repetition, and experience plus repetition is how our algorithm slowly learns to recognize this pattern. And so the reason why I picked JavaScript to show you a little bit about machine learning, how to implement machine learning algorithms, is, for one, JavaScript is great. And for the other thing is that client-side ML can bring several advantages with them. For example, you might have a speed gain because maybe you're on a bad network and you don't want to do a lot of requests to the server and back to the client. And maybe it's just a question of availability. Maybe you're in China and can't reach the server. Or it's just simply about security. Maybe you don't want the training data to leave your client. Maybe it's sensible data. So all those can be good reasons for client-side machine learning. So in this edition, I want to show you how to predict complementary colors. So complementary colors are basically like the opposite color. So for green, for example, can anyone tell me what the complementary color of green would be? I think so, yes. Yeah. So you can calculate the complementary color mathematically, but in this case, I just want to show you how you could approach the complementary color by doing machine learning. And the reason also is that you can create a lot of training data without having to set up a honeypot somewhere and like mine a lot of data, which is just very tedious. Because we're able to just compute them mathematically, it's very easy to generate a big data set. And the way I'm doing it, I'm trying to be as hands-on with code as I can, so trying to not do too much math to keep it simple and light. So first we have to start with some terminology. So there we have inputs, and we have a function, and we have an output. That is the same as in every kind of expert system conventional programming situation. But in machine learning, we call the input the features. So you can have one input, or you can have several inputs. Those are called features. Then we have a function, which is the network, or each node of the network can also be considered a function. But adding all those nodes behind each other is kind of like a big function. And then the output is what we call a prediction. And the prediction is always depends on the network, the configuration of the network. And then additionally to what we have in conventional programming, we also have a desired output, which is the one that we're trying to get to by training. And the desired output is called the target. So in machine learning, you have a network, you feed it features, you get a prediction, and then there's like a desired output that is called the target. And thus, these features and the target, those are the elements of our training data. So what we saw before as the input and the output, basically, is our training data. All right, so code, just to make it a little bit clear. First of all, there's this TensorFlow.js package, TF.js, and we have to import everything apparently, because there's some dependencies in between that is really hard to get separated from each other. And then I have this function where I can generate the data of any size. What I'm doing here is, first of all, I need two arrays, one with the features and one with the targets. The idea of the complementary colors is that our features are an array, a one-dimensional array with 3 elements for the RGB values. So the input color, one single input color is one array with 3 elements, and the complementary color also is an array with 3 elements. And then we push these elements into the big array, and we normalize. That's just a mathematical thing that we don't need to necessarily get into, but it makes it just easier to make it clear to the algorithm that there's a value between 0 and 1, and it's way easier to understand than telling it, oh, and the highest value is 255, by the way. So 0, 1, better to understand for the algorithm. All right, so we have an array with arrays, a 2-dimensional array, and we have to basically define a shape for the features and the targets, which is the shape is the size of the data and the size of each of these input values, basically, which is whatever the size is, and 3. And then we return an object that holds the features and the shape, but then puts them in this kind of TensorFlow tensor, And the tensor is basically a matrix or a multidimensional array. In this case, we're creating a two-dimensional tensor, two-dimensional array that holds the features, and we also tell it the shape of the array. All right, so I added this checklist so we can go through it together, what we need to train and build and train our machine learning example. So we always come back to the checklist. And we started with generating data. This already we have done. And then the next thing we need to do is create some kind of network that we're gonna use. We're gonna do something amazing with this network, and in the end, we're gonna get some profit out of it, hopefully. So, okay, data we already have, great. Now let's talk about the network. So for the network, I'm using TensorFlow.js. You've already seen that I'm basically putting the normal targets and features arrays into TensorFlow arrays. TensorFlow.js, in case you don't know TensorFlow, the original with Python, is basically just an implementation of the same principles that TensorFlow in Python uses, just in JavaScript. And the nice thing is that it uses WebGL to leverage the GPU for massively parallel calculation, which makes the training really, really fast. But you have to let it run in your browser. So we're gonna have to build a neural network with TensorFlow.js because all it can do is build neural networks. It cannot do any other kinds of machine learning, which is fine because neural networks are the coolest anyway. And the way that networks work are basically, they are groups of layers. So this is a layer, it has 4 nodes in it. And you can stack other layers on top of it, and it can have different numbers of nodes. And it needs an input layer in the front and an output layer in the back. In this neural network, each node is connected to all the nodes in the following layer. It doesn't necessarily have to be that way, but in this example it is. And as you can see, every node connected to all the nodes in the next layer, and so on. So if we look at each node, this is a single node in an entire layer, and it receives the inputs of all the nodes in the layer before. And what it really basically does is just add those inputs together, and then calculates an output and just passes that output to all the nodes in the next layer. So now you're thinking, if all the nodes just do this, then all the nodes output the same number because it just adds x1 plus x2 plus x3. So the point here basically is that these values are not just added together, they are multiplied by a weight. So each of these inputs get like a weight of how important this input is for the pattern we want to train. So we could learn, for example, if our input was RGB and then, I don't know, brightness, for example, we could slowly learn that brightness, which would be the 4th input, is not as important as the other ones are. So it gets a really small weight with which it gets multiplied. And this, you have to imagine that it happens in every node in this layer. So this is why we need like parallel calculation of big vectors of numbers or big arrays of numbers. So these weights I just talked about, they are property of the node, so they belong to the node. And we have one weight for each input. So x1 gets another weight than x2, of course. And then also, these weights basically determine what the model looks like, what the model outputs. So what we actually train are these weights. Okay, so the TensorFlow, the heart of TensorFlow is the concept of a tensor, as the name already says. And a tensor basically is one of those layers that I just showed you. The tensor just makes it easy to do vector and matrix multiplication, to do it parallelly, so we don't have to wait a long time for each sequence to end before we can do the next one. And the vectors and the matrix basically represent the columns and the rows. So each layer basically represents a column, and each row is represented by, or each row represents a data set that we're training on. And we're just training on a lot of data sets at the same time, and then take the results and then train on them. But I'm going to show you later how it exactly works. So the dense layers, which are a specific subset of layers, but it's not that complicated. Just wanted to show you once. Those are the ones where each node is connected to each node in the layer after it. So if I'm calling a dense layer, I want the node to be connected to each of the nodes in the next layer. What happens in the node is basically we're calculating x1 times weight 1 plus x2 times weight 2. Then, if I want to, I can add an activation function to it, and I'm just going to put the y into this activation function. There are a bunch of different activation functions that TensorFlow.js allows us to have, and we're going to talk about one of them later. And then if I want to, I can also add a bias to my result, which is just used. So it could be that y is 0, and then the next layer would think that this node was not activated because it gets 0, because if I'm multiplying 0 with something, it just disappears. So by using a bias, I can basically tell the next layer, oh, okay, so this value was really small, but it was activated. Okay, so let's look at code, because that most of the time makes it easier to understand. On the right side, we have this helper kind of document that I just put on the right side, so it makes it easier to understand what I'm doing here. And then on the left side, I'm setting up a network. So I'm starting with creating this model, which is just calling TF sequential. Sequential just means I'm adding a lot of layers sequentially behind the next one. Then I'm going to add a dense layer to this model. And the way that we're doing is just basically taking this model, this TF sequential, and then adding TF layers dense. And then I'm passing a config how this layer needs to look like. So in this case, I want the input dimension to be 3, because I have an array with 3 elements. I want to have the input dimension 3. And I have 3 units. In this case, this is the input tensor. I'm just basically representing the same input values that I got as a layer. So input dimension and units are the same here. And then I'm adding a lot of other dense layers, which just have more units. So units basically denote the number of values that I'm going to pass to the next layer, because it's like 64 units. I would have 64 nodes, and each node outputs one different number. And then for each of those, I'm using a bias just to shake things up a little bit. And then in the end, for the output layer, I'm adding a layer that has 3 units again, because of the 3 output elements in the array. And I'm using this activation functions, which is called ReLU. The ReLU function, ReLU is short for rectifier linear unit, and all this ReLU function does is basically, if the value it gets is smaller than 0, it will output 0, and if the value is bigger than 0, it will just output the value. So by doing this, I'm just eliminating all the numbers or the results that are smaller than 0 and just outputting 0 for that. All right, so this is how I would set up a model or a network. All right, so going back to the checklist, we had the data before. Now we created a network. And now this magic kind of thing begins. That is basically the magic core of machine learning for us to get the profit. All right, training. Any one of you have ever done machine learning training before? All right, that's 3 people. So basically, training just it's a concept that sounds complicated from outside, but actually it's a very straightforward idea. The idea basically is, for training, you have to find a metric. You have to pick a metric that somehow represents how good your network predicts things. Once you have that metric, you just change something, and then you check the metric again. And if it's better, that's good. You just continue doing this thing. If it's worse, then you just do another thing. This is the base idea of training. So how does it work? So I'm trying to visualize something here, and if you don't understand it, just yell it, and I'm just trying to explain it in a better way. So in this graph, I'm having the input values here. So this is a one-dimensional model. I'm just feeding it one input instead of the 3 inputs that I would have to do for complementary colors. So these are the possible input values from 20 to 200, and these are output values from 20 to 100. This curve represents the target. So basically, in the real world, this is the thing that I wanted to be when it's done, that I wanted to predict when it's trained perfectly. If I input 200, I want the y to be somewhere at, like, let's say 90. If I input 80, I want it to be like somewhere by 80. If I input 20, I want it to be like maybe 18. This is the target. This is my prediction right now. So this is what my model predicts right now. It's pretty far away. These points for one input, the target point and the prediction point, this is basically the cost or the loss for this particular input. So if I put in 100 and I get the prediction of about 40, then this is the loss, the distance. And I'm not doing it for just one point, I'm doing it for a lot of points, or maybe all the points of the data set, of the training set. And all of these distances are my cost or my loss. So as I said before, I'm not doing this for one data point. I'm not training just one data point. I'm training a lot of them, and I'm taking all of them, putting them in some kind of function, basically just to represent all these distances. And this is the metric that basically tells me how good or bad my model predicts things. All right, so I have the metric. Now, how do I change things? This is kind of more complicated, so I'm trying to really simplify. But basically, I'm using something that's called an optimizer because it optimizes my model. In this graph, so this is what I'm trying to explain here. I have weights in the x-axis. So basically, for any given x, I multiply it with this weight. And these weights are, remember, that are what we're trying to train. So we're trying to change these weights in a way that our prediction and our target are really close together. This is our loss, the y-axis, and the loss should be as small as possible because the loss is the distance between our target and our prediction. So when I show you this curve, what this basically means is when my weight is at around 40, the loss is also around like 50. When my weight is around 120, it's like 10. And it seems to be that if my weight is around 100, it's the smallest possible weight that I could ever reach. It's the smallest possible loss that I could ever reach, sorry. So intuitively, we can already say, so we want our weight to be somewhere around here because we want our loss to be as small as possible. And this is kind of what the optimizer does. We're starting at some random point because the weights get initialized randomly. And then from there on, the optimizer just tries to change the weights in a way to get closest to this point as possible. The way it does that is kind of mathy, but it basically checks the slope of the curve here and just tries to find a point where the slope is is not as steep. And the sizes of the steps it takes here are denoted by something that is called a learning rate. So a small learning rate would mean that we're not doing as big steps as here, and a bigger learning step would mean that we're doing bigger steps. All right, so this is, this should have been nicer, whatever. So this is basically how we set up training with TensorFlow.js. We're starting with a learning rate, which I just chose arbitrarily here. I'm usually just taking some number and then trying around a little bit. Feeding this learning rate into an optimizer. This optimizer, SGD, is called stochastic gradient descent. Doesn't really matter for now. Just trust me that this is a good one. And then I have to compile the model by telling it which optimizer it needs to use and which loss function it needs to use. So the loss function just represents the difference between the target and the prediction. And in this case, I'm using the mean squared error. Again, just trust me, it's a good one. We can talk about others after the talk. All right. Okay. So we have our data, we have our network, we have set up our training, haven't run it yet though, so it doesn't really do anything, but we have set everything up. So next step would be to run this training algorithm basically. And what's happening while we're running is kind of just the magic of machine learning. I'm trying to, again, visualize to make it more understandable. So we're starting out with some data, and we're feeding the data input to the input of our network. Let's say this is 1. And then it does a lot of calculations, feeding all the values through the network like I showed you by multiplying with the weights and adding a bias, blah, blah, blah. This is called forward propagation because we're propagating this data point to the end. So we're basically doing a lot of different representations and calculations, and then we're ending up here at the end of the network or the output. Then we're taking from the data the desired output, the one that we wanted it to have. In this case, it's not exactly what we predicted, so there is a difference. There's actually a loss. The loss, in this case, I just subtracted from each other. In this case, the loss is 1. In reality, we would do this a bunch of times, and it wouldn't be 1, it would be a vector or an array of a lot of different costs. And then we're taking these costs and feeding them to the optimizer. And the optimizer takes that and goes all through the network again and changes the weights. This is called backpropagation, mainly because it does the exact opposite. Instead of taking data and moving them forward, we're taking data from the back and then moving from the end and moving back to the front. And the optimizer is able to change the weights in such a way that it thinks, okay, if I'm changing it here and here a little bit, then I will be closer to the result. I will reduce the cost as much as possible, or as much as I am allowed to reduce them, because it depends on the learning rate. All right, so, oh man, I made such nice slides, and then I just forgot to move this thing to the back. Anyways. This is the wrong thing. Oh, I'm sorry. I apparently forgot to delete those 2 slides in the middle. Anyway, so here we are. No, this is the wrong one. Ah, damn. Okay. We're back. All right, I'm beginning with a batch size and an epoch. So a batch size is the number of training data I'm taking for each run, basically. For each time, I'm just taking a number of the batch, not the entire training data, and just taking this part because it's a lot of data, and it will just stop everything on your laptop if you're just running like 10,000 data points at the same time. And epochs denote how often you want to go through all your training data. So if I have a training data set of size, let's say 64, and epoch 5, I would have to run it 10 times because I have to run 2 batches for each epoch. I have to run 2 batches to go through all my training data. After I have defined that, I'm calling the fit function on the model and passing it the training data. I'm going to have to pass the features and the targets apart from each other. And then there's a config object where I pass the batch size and the epochs. I can also pass other things here, but yeah, not that important right now for this thing. And then this is an async function. I'm getting the losses, and I can also get some other metrics if I wanted to, but I left them out here. And I'm calculating the average loss. So I'm getting a value for each epoch. So in this case, this array would have 5 elements in them, and I'm just getting the average loss and then returning that. All right, so you all understood everything, right? You're just super clear now. Okay, cool. So I want to demo this. Let's see if I can do this, because this is, well, at least I don't have to increase the view size. Okay, so what I want to do is predict a color. It's always the same color, but I could just give it random colors, but then it's harder for us humans to see how well this learns. These numbers are changeable, so we can play around with them a little bit, or you can play around with it a little bit if you want to see what happens when we change these different variables. So let's see. So let me stop this real quick so you can see what happens. So this is our input and never changes, and the target also never changes. This is the color we want to predict. It's the complementary color. The first time the network is completely untrained, so it just outputs whatever random stuff. And this is the thing that it actually predicts. And we're expecting this column to get closer to the target column. On the right side, I have the cost. The cost should get smaller. We want it to get smaller. We want to get better. And the accuracy should get better because the accuracy basically is the number of times we predicted correctly divided by the number of times we predicted anything, I think. So let's see. This should... Okay, so I'm just starting anew, apparently. So this should get better over time. And as you can see, it actually does already a pretty good job, actually. It's actually pretty quick that it predicts the complementary color to a point where we as humans are not even able to really distinguish the two colors, but it's not perfect. So as you can see from the values themselves, it's not perfect, but for us, it's pretty hard to actually see the difference. It's very hypnotic, I know. But just for you to know, I'm done already. So if you have any questions, I'd be happy to answer them. If I went too fast, I can go through the slides again and then explain single things that you missed. Otherwise, you can check out my repository. Let's see. Okay. So, okay, links. So there's a repository that has this current version that I just showed you because it was an actual live demo. Hooray. And you can just check it out. It's already built. You just have to start a web server on the dist folder to test it. There's deeplearn.js.org, which is now tensorflow.js.com, I think. So this is not working anymore. Just Google TensorFlow.js. This used to be the example. I think they deleted everything now. Yeah, so the long story is I went to a conference, I gave this talk, and then when I was done, someone came up to me, hey, do you know TensorFlow.js? And I'm like, oh, no, but it sounds like the thing that I just gave a talk on. And they deleted all the old documents and all the old examples and everything, and nothing was backwards compatible anymore. So I had to port everything and had to migrate everything. So I don't think this example is still up, unfortunately. But okay, so here you get a very good and very basic explanation of deep learning that actually works, lets itself be ported to TensorFlow.js or TensorFlow very easily. Yes, font awesome, font icons, yes. Oh, and we are hiring as well. Yay. Okay, thanks. Yeah, I'm sorry about the slides. I was half asleep when I redid them. Yes, gentleman in the back. Yes. So, yes, how did I looked at the example and then just did what they did. That is, yeah, but apart from that, if I was starting a new project, I would probably go with binary numbers because that makes sense, and just start from there and then see, just again, try to change things and see, does it work better now or does it work worse? Or if it's not that much better, then maybe it's not worth the hassle. Yeah, I don't have a best practice, unfortunately. I'm just mainly looking what other people do and then just try to adapt that to what I want to do. I started with very small layers, like 8 or 16, and it took me just a long time to train anything, so I just increased the number at some point. But yeah. I guess there is, but I'm really not like an expert on it, so I don't really know. I haven't read the one article that tells me this is how you're doing it, unfortunately. But if you find it, let me know. Any more questions? Yes. Mm-hmm. Okay, I don't give new inputs because I found it makes it harder for humans to see that it's getting better, which is what I wanted to show, but I could do, so here in this, I'm giving an input color, and I could go color helper. Oh, this is live coding now. Color helper, get. I don't know if it works because I haven't done this a long time. 1 second. Oh yeah. What do you want to see, by the way? What is the? Okay. Thanks. Yes. Oh, thanks. Yes. Oh, okay. Yeah. Yeah, so you could export the network. I'm not doing it, so basically I'm just training it every time because what I want to showcase is basically how it gets better. But you can export it, save it wherever as a file, and then, for example, use TensorFlow, the Python one, to reload this model and do something else with it. You could do that, but I'm not doing it in this example. Does that answer your question? What am I doing with it? I'm traveling around and giving talks on how to do this. What could be the use case? Yeah. Mm-hmm. Oh, so the way the network is trained is not by giving it random inputs necessarily. Well, yeah, I guess it can be part of it, that you're just giving it a lot of different inputs and a lot of different outputs for it to train. And then you could maybe, if you have a color palette that you like, you could teach it to predict a color that you would like given any color. So you would feed it an input color and then say, well, you know my tastes, so give me a color that matches this color that I would like, for example. Think about it. Think about the possibilities. No, yeah, yeah. Yes. So the purpose ideally would be to train it, to save it, and then load it somewhere else, and then just use it to predict things. Yeah, exactly. So you could also train your network with TensorFlow Python on the backend, train it a lot, put it somewhere, S3, whatever, and then from the client, just load the model, and you don't have to do all the training anymore. Just load the model and then make predictions on it. Because the prediction is basically just feeding something and getting something out without all the backpropagation loss thing. Yeah, you wouldn't do that all the time, of course. Yeah, I think the question was just that you're not doing the training every single time. No, of course not. You're saving the model, exporting it, because you'd only basically you need the weights. The weights are what defines how you're gonna predict this. So if you can store them somewhere in like a matrixy kind of way, so you know you can reference them back to each node, then yeah, you only need that. You don't need to retrain it every time. Yes. Yeah. Yes, so I didn't put the link there, but I started out with the machine learning network on Coursera, and I highly recommend it, although it's very, very mathsy. But yeah, so basically deep learning, or the learning with neural networks, is just one subgroup of machine learning. There are a lot of other machine learning algorithms. Some of them aren't even that deep. They're not even that complex. It's just pretty simple machine learning, actually. In this case, I just wanted to showcase TensorFlow.js, and they do deep learning, which is, yeah. No, you can't do support vector machines or whatever. They're exclusively for neural networks. Yeah. Okay. Thank you.
Hello. Do you need this one? No, you have your own.
No, but I want.
Yes, you can take that one. Or and then use this. Yes.
Thanks. I will try to connect to the Wi-Fi.
Oh. Okay. Well, while Damien is setting up, trying to connect to the Wi-Fi and everything, let me introduce Damien. So, Damien is the newest addition to our NLHTML5 team, and we're very happy to have them support us.
To present myself quickly, I'm Damien. I'm from France. I think you will hear that. And I'm user-centered designer. I was a developer a few years ago, and I chose the design side at one point. And I love raccoons. I really love raccoons. So that's why Raccoon Studio, and I'm also working at Fairphone, which is an ethical phone, and we're trying to build the world's first ethical and modular phone. So yeah, that's quite nice as a project. And we will discuss about, as I said, readability. And I spend my day, I don't know if the mic is working a lot, but I spend my